Those are online. Am I audible?
Yes, sir.
Yes, sir.
Sorry, guys. I have to see the time. My mistake. My date, 17. Just give me a minute time. We'll get started. Can come from. So those are online. Are you able to see the screen? You're able to see my screen? Can I have some response, please?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Shall we get started? So today, let's start with the next chapter. Matrices. Okay. So, any idea about this chapter? Have you learned? How many of you have learned? You have also learned. Let's start with continuity differential. Calculus part. Okay, that's fine. So most of you have seen matrices and determinant also, right? What do you know about that? You've learned? So what do you think? 2/2, 3/2, 2/3, 3/2. Right? Any way you want. Right? What's that? So you just want to start with saying that this is considered to be one of the easiest steps. Right? Because it is all about playing with numbers. Few numbers, you just arrange them in some kind of a format about which I discuss. And then do some mathematical operations. Right? See, but that's not my objective. Right? My objective is more focused towards your case-based questions. I want you to understand why you're studying the first place. It's not about this chapter is existing, okay, let it be there that anybody can learn from anywhere. Right? So if I put a question of Y matrices, what will be your answer? Okay, matrix means some kind of an arrangement. Okay, I don't know what it is as of now. I've not discussed it about that arrangement and all. But if I put a question of Y matrices, what will your answer? And to give an answer to this question, it is not something new. You already know the answer. Okay, which you have learned in your 10th grade, but they didn't use this book. See, I'll give you one example related to why where it is applicable in mathematics. I'll give you the other set of applications where it is applicable in real life. Okay, so first question is, if I have a linear equation like this, 2x plus 3y is equal to 5 and 3x plus 2y is equal to 7. Okay, I randomly give you two linear equations. If I ask you to solve this, I'm sure that everybody sitting here might be able to solve it. Right? So what are the method you choose? What are all the methods you know in the first place to solve two linear equations into variables? So you can think of substitution method. Then you will think of elimination method. Then anything else that you people know? Have you heard of something called as cross multiplication? You've heard of this?
Yes, sir.
Basically, first we'll write it in the standard form like this. Then 3x plus 2y minus 7 is equal to 0. You write it in the standard form. Then what you will do is you will start with the middle term. You write them like this. 3, 2. Right? Then you will write minus 5, minus 7. Then you will write 2, 3. Then what you will write? Then again you will write 3, 2. So you will start with the middle number. You write in this order and come back to the same middle number. Right? Here you will put as x, y, and you put 1 here. Right? So it will be x divided by, what is the next step? You will cross multiply them and subtract. So when you do the cross multiplication, you do from left to right. So 3 into minus 7 is minus 21, minus of minus 10 is equal to y divided by minus 5 into 3 is minus 15 minus of minus 14 is equal to 1 divided by 4 minus 9. So when you solve this, you will get the value of x and y. Right? Now the question is, what is this operation that you have performed here? You perform something called as cross multiplication. That is why the name of the method is cross multiplication. But the important question that we need to answer is, this is the idea based on which the concept of matrices and determinant come into picture. Okay, so what you're actually doing, is you're doing the same, you're dealing with the same set of linear equations, but a different approach of solving it.
Sir,
Tell me.
sir, your voice is not audible, sir.
Is it breaking or is it not audible?
Sir, it is low, sir. Lower கேக்குது.
Oh, okay. Now is it better?
Yes, sir.
No, I think it should be fine.
Yes, sir.
right? Is it better now?
Yes, sir.
Sir.
Divya, is it better now?
Yes, sir.
Okay. Yeah. See, now I hope you could understand why matrices is important in terms of mathematics in the first place, right? So one of the applications is to solve two linear equations. So this is the idea from which this concept itself got invented, right? Basically, what you have is all you have is numbers. The numbers are arranged in a proper structure. See, for example, what I did here is cross multiplication. If I take these numbers and put it within square brackets, that is what is called as matrices. That is what is a matrix basically, right? In mathematics, you call it as matrix. If you're a computer science student, you will call it as an array. Right? Basically, what is an array? It is also arrangement of numbers in a structured format. That's it. So all that we are going to learn here is if I give you a set of data, how are you going to place it in a structured format, right? So to put it simple, do you all deal with Excel? Have you dealt it? You know how to handle Excel? So what does an Excel have? It has rows and columns, right? So that is what you need to do, right? That is an example of matrix, right? So having said that, let us see what are all the real-time applications of it. So when I talk about the real-time applications, right? So where we actually use this concept of matrices to process things. One of the applications is computer graphics and image processing. So when you talk about these things, right? Whenever you talk about images, right? So when I talk about images, if you see the previous, like even before these digital photographs used to come, I'm not sure how many of you have seen it. You see that they take a negative to a closed room, in a dark room, they'll wipe it off under a liquid and they'll be taking out the photo. I'm not sure how many of you have seen it. You have seen it, no? At least in movies or something, you would have seen it, right? So they do it, right? So what happens there? There is a film that is processed, right? But nowadays, what is happening? You're dealing everything with the help of your mobiles, right? When you capture a picture, you zoom and see. So when you zoom and see, after a certain point, what is that you will be able to see? You will be able to see small boxes like this. What are those boxes called as? They're called as pixels. So when this data is getting stored in that memory, right? Memory of your phone, it will be stored in the form of matrices on. So whenever you're processing something, it will understand. See, you're doing a color change, for example. You want to select a particular area, you're saying a color change is to be done. What mathematical operation is it going to run in the back end? See, if I look at the screen, right? If I look at the screen, I say that this is made up of many pixels here, many pixels which we are not able to see. Like everything is combined, you are able to see it as a single image. But if you try to break it down into small parts, it is going to have. See, I'm writing it here. How does it know that the data is getting stored here? What logic is this computer going to use? It does not have any brain or something, no? So it needs to take those coordinates into picture. Can I say coordinates also? The reason why I'm telling this is you can also relate your coordinate geometry to matrices. So why I'm saying coordinates is because in matrices you speak in terms of rows and columns, whereas in coordinate geometry you will speak with respect to origin. You'll speak about the position of this object. How will you write it in 2 dimensions? You'll write it as, for example, you write it as 9, 15. So what is the meaning of this? What is the meaning of that 9, 15? This point is at a distance of 9 units from the origin along x direction and 15 units from the origin along the y direction. That is the meaning of that point, right? So what I can do is I can actually put it like this also, 9, 15. I'll be able to represent it like another format also. Are you able to understand? So this is one such application, real-time applications of matrices. Similarly, when it comes to data science and machine learning, I told you just now. So you would have heard about this course recently, data science. How many of you have heard about? You know, right? So what does data science speak about? Fairly data. I'll give you a set of data. You need to analyze the data and give me an output. So can you give me an example of what it does? Like how is it actually helpful in machine learning? Okay, that maybe you can talk about economics and finance. Okay, this is also there. Okay, you go with business. Yeah. So you told about business profits and losses, right? So how do you predict? Very good. Very good. See, suppose let's say there is a company which is there for 10 years. They have a specific set of data right from the time they started. They are saying that every year they had these many customers. Due to these many customers, they got this much revenue. Will it be helpful? Will the data be helpful for you to predict the future? So that's what is data science all about. So with that, if you want to create an artificial intelligence program where you want to train the machine, you can write the programs accordingly. So that's what sits there. But here also what is used? Matrices. Okay. Economics and finance. Again, when you talk about the finance, let's take as simple as the data set of putting things in Excel sheet, right? You want to file a tax or something, right? You can use this matrices. Are you able to understand? So these are all the real-time applications of matrices. Okay. Now coming back to the simplest part, that is your textbook. All that we need to learn in this chapter is you're not going to learn the real-time applications or something. Why I introduced this, when you look at the chapter, it should feel small. It should feel easy for you, right? So when it comes to the book application, there are some basic information that will be given and you have to convert it to a matrix format. That is what you need to do. See, suppose all the data I've taken is from your NCERT only. Okay. Suppose there is an information like this, stating that Radha is someone who has 15 notebooks. Okay, 15 is a number. So you can state it like this. You can always represent it in terms of normal English, saying that Radha has 15 notebooks. But how will you represent the same in terms of matrices? What you can do is you can think of the square bracket, put the number between them. So what is it to be understood? The number of notebooks Radha has is 15. Suppose we say Radha has 15 notebooks and 6 pens. So how can you put it? You take a square bracket, you put it like this, 15 and 6. What is the meaning of this? She has 15 notebooks and 6 pens. So because you're trying to say, you will not use any comma or something. The numbers are represented within rectangular boxes. You will understand that when I introduce matrices. I didn't give you the definition of matrix. I'm only telling you, if there is a data like this, how are you going to represent it? Yeah. But if the most of see, if you can write it vertically also, but that depends on how you are naming the data structure. So what he is asking is, can't I write it like this? You can write. But only thing that you need to tell the person who's reading your paper is, you're going to say that this represents notebooks and this represents pens. It's about how you're going to communicate. If you write it like this, you're going to say that this represents notebooks and this speaks about pens. So tomorrow, like next, what will happen is, if there are few more people also getting added to the data set, what you can do is you can choose either of the ways and represent it. Are you able to understand what I'm trying to say? So having said that, Radha has 15 notebooks and 6 pens. Meaning, so here if you observe, there are 3 people. So here, how are you going to write? If I put a box like this, so how can I write it? You tell me. So you want to take in this order, 15, 6, so that the columns, generally verticals or columns, since you already know, I'm trying to relate it to Excel sheet. Horizontals are called as rows, verticals are called as columns. Okay. So in the first row, what have you written? 15, 6. The first 15 represents notebooks. Second 6 represent pens. So this is corresponding to whom? What about Fauzia? So if I talk about Fauzia, that's it. 10, 2. Then who is there? Someone, Simran. Okay. So 13 and is the point clear? So this is all we are supposed to do. Okay. Next. So based on the previous discussion that we had, now we can actually give a definition to matrix. So let's see what a matrix is. Matrix is basically an ordered rectangular array. What do you mean by ordered? The order is very important. Suppose in the previous case, you can tell me that the numbers here are 15 and 6, sir. So I'll write 15, 6, 6, 15. Can I say that they both are same? No, because you have changed the order. Order is very important. That is why the definition itself has the word called as ordered. So it is an ordered rectangular array of numbers or functions. Generally, what we use inside is going to be a number, or it can be a function also, right? Numbers or functions, where these numbers or functions are given a name called as elements, or they are also called as the entries of the matrix. Okay. So matrix is singular, matrices is plural. That's it. Okay. Did you understand what is the definition? For people who are learning it for the first time, listen to this. A matrix is basically an ordered rectangular array of what? Of, don't look at it, of numbers or functions. And those numbers or functions are called as elements or entries of that matrix. Okay. So generally, whenever you represent a matrix, right, it is always represented using capital letters. It is something similar to how you represent a set. Set name of a set is always represented in capital. Elements you generally represented in lowercase, because when you talk about a set, element can be letters also. Here mostly will be numbers. Okay, that is why I'm not talking about how the element should be represented. Okay, so A is the name of the matrix. Okay, it has the elements -2, 5, 0, √5, 3, 6. So how many rows do you have? 1, 2, 3. Horizontals are called as rows and the verticals are called as columns. So how many rows do we have? 3. And columns? If you take this B is going to be 2 plus I. 2 plus I is a complex number. 2 plus I, 3 minus half, 3.5 minus 1, 2, √3, 5, 5 by 7. So it's a combination of irrational, rational, complex. Every number is there. So basically real and complex numbers, right? So B is a set which has 1, 2, 3. 3 rows, 3 columns.
3 columns.
What about the C? 1 plus x, x cube, 3, cos x, sin x plus 2, tan x. 2 rows, 3 columns. So this is a combination of, not combination, this is only having functions inside. 1 plus x is a function, x cube is a function. Can I say 3 is a function? No function. What function is it? 3. I told in this everything is a function, no? It's a constant function. 3 is a constant function, right? So cos x, sin x plus 2 and tan x. I hope you're able to understand, right? So I can make a note of this. So write down the definition. Wi-Fi connect. Those who are online, are you done with this?
Doing, sir.
So let me know if you can proceed. Okay. This one, huh? Okay. See, the next topic that you're going to discuss is order of a matrix, right? So how are you going to communicate to someone saying that this is the order, or these many rows and these many columns are supposed to be there? There is one way. You always draw that rectangular box and show it. Or else, is there a simpler way in which you can communicate so that they will be able to build the elements out of them, out of their own? Okay. So if I take a matrix which has m rows and n columns, right? How many rows? If I take a matrix which has m rows and n columns, then it is said to be a matrix of order m. You write it as m, it is cross n, right? It's like an into mark. So it is m cross n, or simply you can say it is an m cross n matrix, right? But how do you read it? It is read as m by n matrix. You can say m by n or m cross n. It's accepted. Okay. So if you take the previous examples into consideration, right? If you take the previous examples into consideration, can you tell me what is the order of the first matrix? It has 3 rows and 2 columns. So it is going to be a 3 cross 2 matrix. So what about the second one? It is a 3 cross 3 matrix. So it's a 3 by 3 matrix. Then what about C? It is a 2 cross 3 matrix, right? So if you observe in the matrices which are 3 cross 2 and 2 cross 3, how many elements are present? There will be 6 elements. Basically, it will be the product of these two. So 3 into 2 is going to give you 6 elements. Similarly, if you observe B, the matrix B has how many elements? It will have 9 elements because it is 3 into 3, right? So this is the basic English way of understanding what are the number of rows and columns. Okay, accepted. Now the thing is there a general form in which you can represent so that the person who's reading your paper is able to build a matrix on their own, right? So in general, if you talk about an m cross n matrix, it has the following rectangular array. What is it? You write capital A is equal to, how do you write? You write capital A, which is going to be the name of the matrix, right? Is going to be capital A is equal to name of the matrix, which is written as A ij, and it is of the order m cross n, right? So Aij stands, small aij stands for element, capital A stands for the name of the matrix, and m cross n stands for the order of the matrix. Okay, where what can you say about where m lies? Sorry, where I is going to lie? I is going to be greater than or equal to 1, and it is going to be less than or equal to m. Right? Similarly, what can you say about j? So this is I, this is j. What can you say about j? J will be greater than or equal to 1, less than or equal to n. Right? I hope this point is clear. No? Now the question is, in general, if you write Aij, it is going to be element lying in which row? It will be in the ith row and the jth column. See, for example, if I want A23, what is the meaning of it? Element in the second row, third column. So second row, third column, this is going to be there. So it is going to be A23 like this, right? Now the question is, when I talk about I, we are saying it is going to be greater than or equal to 1, less than or equal to m, right? So what is going to be the first element? First element will be A1. So I'm only concentrating on row. So it will be A1. And what will be the last element? AM. So A1, AM. Similarly, what about the column? The first column can start with 1 and the last column with end with n. So here it is going to be A11, and here it is going to be AMN. Are you able to understand this? So this is another important point that you need to keep in your mind. Okay. So just make a quick note of it. Shall I proceed? This is not equal to so I can vary that. It's a variable. I can vary anywhere between 1 to m. It can be 1, 2, 3, anything. But 1, 2, 3, like this. The last number it can take is m. What would be the number? Am minus 1. Okay. See, these things are more important because this is what will be asked in your exam. They'll give you the general form and ask. Right. So here I want you to make an important note, right? So we'll follow the notation. Capital A is equal to Aij of m cross n to indicate that A is a matrix and which is of the order m cross n. Okay. Secondly, we will consider only those matrices whose elements are real numbers or functions which take real numbers. So we'll not use complex numbers here. Okay. So whose elements are going to be real numbers or functions that take the real values. So we are going to take only them into consideration. So shall I proceed? Right. Now if you see. So based on the above discussion, can you tell me how to represent this in a matrix form? So let us see example number 1. Consider the following information regarding the number of men and women workers in 3 factories, 1, 2, and 3. Right. So factory number 1, 2, and 3. So there are men workers and women workers. Represent the above information in the form 3 cross 2 matrix. And what does the entry in the third row and second column represent? So how are you going to write it in a 3 cross 2 matrix? So take 30, 25, 25, 31, 27, 26. So what are you going to say? This is going to belong to the first factory. This is for the second factory, and this is for the third factory. Here it is going to be men, and here it is going to be women. Here, it is simple. Now, what is the next part of the question? What does the entry in the third row, second column? So, third row, second column, it is going to be 26. So, this 26 represents number of women workers in third factory. That's it. Right? It's simple, no? Just make a quick note of it. Shall we proceed? Example 2. If a matrix has 8 elements, what are all the possible orders it can have? So there are a total of how many elements? 8 elements. So what are all the possible orders it can have? Basically, it is the number, it is the factors of this 8. So if you start with 1, 1, 8, or it can be 2, 4, or it can be 4, 2, or it can have 8, 1. So there are totally 4 different matrices that are possible, each of order 1 cross 8, 2 cross 4, 4 cross 2, or 8 cross 1. Right. Textbook question, it's an example problem. Don't write the question, okay? Shall I proceed? So in example number 3, we need to construct a 3 cross 2 matrix whose elements are given by Aij is equal to half of modulus of I minus 3j, right? So what are we expected to construct? We are supposed to construct a matrix A which contains the elements Aij and it is of the order 3 cross 2. And what does Aij represent? So each element is going to follow the operation of, or it is going to be a function like half into I minus 3j. Where Aij is given as half into modulus of I minus 3j. So we can start with A11. So what is going to be A11? So when I write A11, in the place of I need to substitute 1, and in the place of j also you need to substitute 1. So it is going to be half into, what will you substitute? 1 minus 3. So how much will it be? Half into modulus of minus 2. Modulus of minus 2 is 2. So half into 2, which is going to give you 1 itself. So similarly, what is going to be the value of A12? Half into 1 minus 6. So it is basically going to be 1 minus 6. So it will be 5 by 2. So what is A13? A13 is going to be half into 1 minus 9. It is going to be 8 by 2 or 4. Oh, sorry, 1. Oh, sorry, yeah. So correction. So next is A21. So half into 2 minus 3. So it is going to be half itself. Similarly, what is A22? Half into 2 minus 6. It is going to be 4 by 2, which is again 2. So what is A31? So half into 3 minus 3, which will be a 0. What is A32? It is going to be half into 3 minus 6. So half into 3 minus 6 is 3 by 2. So what is going to be the matrix? So when you combine everything and write A, it is going to be of the format 1, 5 by 2, half, 2, 0, 3 by 2. So this is going to be the answer. Right. So I hope you all could solve it. Shall I proceed? So the next type that we are going to discuss is the types of matrices. I don't know why it is coming like this. Everywhere it is like that, no? Just give me a minute. Okay. Sorry, yeah. Again a problem. Okay. So listen to this. So the next topic that we are going to discuss is the types of matrices, of which the first one is going to be called as the column matrix. So what are the column matrix? Name is suggesting, no? A matrix which is said to have a column is said to be a column matrix. It should have only one column. But how many rows can it have? Any number of rows, right? So if I take a matrix A, then if I write it as this, it contains elements Aij, then what should be the order? What should be the order of this? Okay, it can be, generally we use m cross 1. So you will not use the same variables here because I is ranging between 1 to m. So you write it as the order of m cross 1. So you understood this? So how is it represented in the form of numbers? So 0, 1, 2, can I call it as a column matrix? So it has only one column and 3 rows, right? So it can work. So this is the example of a column matrix. I'll finish everything, then you can write. The next is a row matrix. So as the name suggests again, if there is a matrix which has only one row, you call it as a row matrix. So if I take the matrix A, then it should have the elements Aij, which are of the order 1 cross n. So it's going to be 1 cross n. So one such example we can think of is, let's say 15, 15, 6, 15, 6, 20, like this. It can be anything. So it should have only one row, but multiple columns are allowed. We can't speak anything about columns, but there should only be one row. You can cover both. Okay. So when you think of a square matrix, right, as the name suggests again, generally, how did we define matrix as? Matrix is basically it's a ordered rectangular array, right? It's an ordered rectangular array. If that rectangle becomes a special type, which is a square, then you call it as a square matrix. So here, what is supposed to happen? Square means it should have equal number of rows and equal number of columns. That's it, no? So a matrix in which the number of rows are equal to the number of columns is said to be a square matrix. So if there is an m cross n matrix, then it is said to be a square matrix when m is equal to n. And generally, how we say is we don't write it as m cross m or m cross n. We represent it as a square matrix of order n. That is how you write it. So A is equal to, if I write Aij, then here if you want to write it as an order, what are you going to write? You will write it as m cross m, or you can also write it as Aij n cross n. So it is basically said as A is a square matrix of order n. So it is understood. Is that point clear? Right. So when you write a square matrix, how is it going to look like? 1, 2, 3, let's say 4, 5, 6, 7, 8, 9. So this is a square matrix of order 3. It's a square matrix of order 3. Okay. Now, okay, I think it is repeated. So if I take A is equal to Aij and we call it as a square matrix of order n, then you have these elements, right? When you generally observe the way the matrices are written, you have these elements A11, A22, A33, it keeps on going like that, right? So those elements A11, A22, A33, so on till ANN are said to constitute the diagonal of that matrix. So this is taken to be the diagonal. It is not like how a square has that both the sides you are going to define a diagonal. It is going to be only from left to right. So from left to right, it is going to represent the diagonal elements, right? So if you take this matrix A is equal to 1, minus 3, 1, 2, 4, minus 1, 3, 5, 6, these numbers are going to represent the diagonal, right? So what are going to be the diagonal elements then? 1, 4, and 6. Am I clear with this? Right? So till here you can first make a note of, starting with column matrix. Textbook. Left to right மட்டும்தான். அதான். அது நான் சொல்றேன் ரைட் டு லெஃப்ட் எடுக்க கூடாது. நான் சொல்றது இந்த ஆர்டர்ல எடு. When we say left to right, it is always from top to bottom. You don't go from bottom. Now, if right to left, if I say, then it is understood that I'm talking about right top to left bottom. So you should not take 1, 4, 3 as the diagonal elements. And now when we think of a square, what comes to our mind? Two diagonal இருக்கும்ல, so we get confused. So another diagonal elements are those elements where the I and J are the same. அதனால பார்த்தீங்கன்னா A11, A22 அது மாதிரி இருக்கும். புரியுதா? So if you remember the order, you can start writing it. What is the order? First is column, then we spoke about row, then Right. Shall I proceed? You finished writing this also? Right. So yes. Okay. The next question is about diagonal matrix. So it is about a diagonal matrix. So now you know what is a diagonal, right? Right. So when you talk about a diagonal matrix, first thing that is to be noted is you can speak about a diagonal matrix only for a square matrix. Okay. So a square matrix B is equal to Bij of order M. It is M cross M. It is said to be a diagonal matrix if all the non-diagonal elements are 0, right? So that is, you take this B is equal to Bij and you write it as M cross M. No? It is said to be a diagonal matrix if Bij is equal to 0, where I is not equal to j. Because for the diagonal elements, how is I and j related? For diagonal elements, how do you take, how is I and j related? They both are same. This is what I told you. When you look at the diagonal elements, I and j are same. So what they are trying to tell mathematically is, so what they are trying to tell mathematically is, if there is a matrix B which is equal to Bij of the order M cross M, then you can call this as a diagonal matrix if Bij is equal to 0. And what should be the relation between I and j? I should not be equal to j. If I is equal to j, it will become a diagonal element. Okay, so how is it represented in the standard form? Observe. So if I take -1, 2 and I write 0 and 0, this is an example of diagonal matrix. Similarly, if I write this as -1, 2, 3, 0, 0, 0, 0, 0, 0. If you look at the diagonal elements, so more than concentrating on diagonal elements, you need to concentrate on the non-diagonal elements. All the non-diagonal elements should be 0. If it is 0, you call that matrix as a diagonal matrix. So these two are examples of diagonal matrix. I hope I'm clear, right? See, since I told you, they will ask you mostly when it comes to MCQ and everything, they can give you these kind of statements and confuse you. So please be clear about it. So whenever you talk about diagonal element, can you tell me what will be the relation between I and j? When you talk about diagonal matrix, how are the diagonal elements? Subscripts are, they're equal. It will be A11, A22, A33, like that. I and j are equal. So for diagonal matrix, which elements are supposed to be 0? Aij element should be 0, where I should not be equal to j. Okay, make a note. School uniform, brother. Shall I proceed? So next is, what is a scalar matrix? Okay. So first what we started with is square. Observe the pattern, okay? Listen to this carefully. Listen. First is square matrix. In square matrix, what should happen? Number of rows should be equal to number of columns. From the square matrix, we went to the concept of diagonal matrix. So diagonal matrix by default is a square matrix. It's a subset of it, right? So for that for the diagonal matrix, what should be the condition that should be satisfied? Non-diagonal element should be 0. From there, you're going to another matrix called as scalar matrix. Look at the way the definition is starting. A diagonal matrix. So when they use the word diagonal, there are two things that are already getting covered. What is it? One is it's a diagonal matrix. Second is it's a square matrix. So to put it simple, scalar matrix is also possible only for a square matrix. That is the first point to be noted. Okay. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. If its diagonal elements are equal, that is, if I have a square matrix B where Bij is equal to n cross n, you can call that matrix as a square matrix if Bij is equal to 0. Why should Bij be equal to 0? For it to become a diagonal matrix. So for the square matrix to become a diagonal matrix, Bij should be equal to 0. Then how is I and j supposed to be related? I and j should not be the same. Means all non-diagonal elements. Is that right? Similarly, if I talk about only the diagonal elements, Bij should be equal to some number k. Right? When I is equal to j. If I look at an example, then what should be the case? Let's say 2, 0, 0, 0, 2, 0, 0, 0, 2. Can I call this as a scalar matrix? So for you to verify that it is a scalar matrix, what is the first thing you need to check? Is it a square matrix? Okay. Second, if it is a square matrix, is it a diagonal matrix? If it is a diagonal matrix, the third thing that you're supposed to check is, are all the elements related to the diagonal the same? If they are not same, then it is not a scalar matrix. So are you able to understand the minor difference? For diagonal matrix, we didn't say anything saying that the element should be the same. For the diagonal matrix to become a special matrix called as scalar matrix, then the diagonal element should be the same. So I want this point to get registered strongly in your mind. Is it clear? Please make a note of it. So I told you some important points, right? Make a note of it. Shall I proceed? Shall I? Okay. So from scalar matrix, there is another important matrix that comes out. That is an identity matrix, which is very, very, very important. Right? So if you talk about a square matrix in which all the diagonal elements are 1. So basically, a diagonal matrix with all the diagonal elements being 1 is called as a identity matrix. So if you come in the order again, what has happened? From square, we took diagonal, and from diagonal, we took scalar, and from scalar, what we can say is the special case of a scalar where all diagonal elements are 1, then you call this as the this is the structure. Okay. So square matrix in which all the elements in a diagonal, right? A square matrix in which all the diagonal, a square matrix in which all the elements of a diagonal are 1 and the rest are all 0 is called as an identity matrix. So in other words, what you say, A is equal to Aij of order n cross n is said to be an identity matrix if Aij is equal to 1 for which condition of I and j, where I is equal to j. When I is equal to j, they become the diagonal elements. So these are the diagonal elements, and I is not equal to j becomes the non-diagonal elements, right? So to summarize it, what did we see? From a square matrix, you derive diagonal. From a diagonal matrix, you derive scalar. From a scalar matrix, if you make all the diagonal elements of a scalar matrix as 1, you call that matrix as identity matrix, and identity matrix is represented with the symbol I. So I is equal to 1 0 0 0 1 0 0 0 1. Is the point clear? Is the point clear? I want you to remember this identity matrix. As I told you, it is very, very, very important. I'll tell you why it is important. Shall I proceed? Yeah. So next one, if you see, we call a matrix zero matrix. When a matrix is said to be a zero matrix or null matrix, if all the elements are zero. If all the elements are zero, why are we even defining a matrix? Right? We need to understand what it is. So if you have a matrix where all the elements are zero, you call it as a zero matrix or a null matrix. Okay. So first, as I told you, there are some important reasons why I told identity matrix is important. In a similar way, zero matrix is also important for you to understand a concept. Okay. So observe, when I use the word identity, right? When I use the word identity, there are two kinds of identities we can think of. One is called as additive, and the second is called as multiplicative. So additive and multiplicative. Suppose I take a number 5. So to this 5, if I add a 0, then what am I getting back? I'm getting back 5. Then the 0 is called as the additive identity of 5 because it is giving back the same number. Similarly, if I take this 5 and if I multiply it with 1, what am I going to get? I'll get 5. So the number which is multiplied with another number is giving back the original number itself. So this number 1 is called as the multiplicative identity. In a similar way, when you talk about a matrix, right, we'll be learning something called as matrix addition and matrix multiplication. Listen to this carefully. If I take a matrix A and if I add a null matrix to it, null matrix is represented by the symbol O. So if I take a matrix and add the null matrix to it, I'll get back the original matrix itself. So are you able to relate it between the numbers? So here it is real number, here it is a matrix itself. Okay. Similarly, if I take a matrix and multiply it with the identity matrix, then what will I get? I'll get back the original matrix itself. Right. So this is an important concept that we'll be using in the future to calculate something called as matrix inverse or inverse of a matrix. Same. It's the same thing. You just call it as pre-multiplication or post-multiplication. Okay. But here, generally, when I talk about A into I, right, I need to ensure that there is a condition that you need to follow for multiplication. Idhula irukra columns, idhula irukra rows should match. Varadu plus panna mudiyuma illiyandra feasibility you need to check. Sometimes A into B will exist, but B into A will not exist. Okay. So that we will see as time progresses. Okay. See, today I've covered all the basics. Going forward, I can go a little faster. Tomorrow, in the first 20 minutes, you will be able to do the exercise on your own. After that, we'll go to the operations like addition, subtraction, and multiplication. Okay. So you can wind up.
Thank you, sir.